Hi everybody. So I received a lot of feedback that it would be really helpful to post all of the math involved in figuring out the absolute VO2 and the relative VO2 for a client based on the ergometry test that we did. So what I have done is I have uploaded a sheet that I completed with accurate math, and you have this sheet as well. This is the sheet you'll be using for your practical. And what I'll do is I'll kind of point out how I got to where I got. I'll walk you through the math so that you can rewatch this video. And if you have any questions, hopefully this will clarify any confusion. So we have Joe Schmo. He is a 30-year-old client and he weighs 160 pounds. So just to take a step out of all the math, I immediately converted that to kilograms. So 160 divided by 2.2 gives me 74 kilograms. Okay, so that's the conversion for that. We took his resting values while he was sitting on the bike without pedaling. His heart rate was 70. His blood pressure was 120/80, and the seat height, which you can see like looking at Joe from the front of the bike, is 11. All right, so what we did is we started the test right after he warmed up. So let's say he did a 2-minute warm up. So this weight was put on at the 3rd minute of exercising, or the second minute of exercising after the 2nd minute. Right at the start of that 3rd minute. So you put 2 kilopounds on. Remember, kilopounds are the same as kilograms. And at the end of 1 minute, we recorded the heart rate at 110. We kept it at 2 because we weren't sure how he was going to adjust. At the end of 2 minutes, his heart rate was 115. That is lower than 120. You want it above 120 by this time, or you want it above 125 by the end of the test. So we upped it to 2.5. And at the end of the 3rd minute, his heart rate went up to 130. And we kept it there because it looks like a good heart rate response. And this is what we got. And then at the end of the 4th minute, we also took blood pressure, which was 140/82. All right, so how do you figure out the VO2 from the data that you get? So looking at step 1 here, the first thing that you do is take the average heart rate of the 5th and 6th minute. So we're looking right here, and we're looking right here. Okay, now I chose questionable ones or different ones on purpose. So 133 plus 136, take the average of that, and you get 134.5. And if you remember, I'll actually pull up my chart. So this is a male. So if you look over here, you notice that there are no halves here. Sometimes we'll do halves when it comes to power, but there are no halves of a heart rate. So what we do is we round it up. So if you have 134.5, you're going to round it up to 135. So that's where we're looking. All right, so I rounded it up here. Step 2 is looking up the absolute VO2. Okay, so the information that you need is the fact that he ended at 2.5 kilopounds. All right, so 2.5 kilopounds, and how I converted that into watts and kilogram meters per minute was each kilopound is 50 watts. Okay, so I wrote that here for you. Each kilopound is 50 watts, so I apologize if I didn't write that in your notes, but I'll make sure that I put it up for you and I share this link. So that means that you have 125 watts. Your conversion for watts to kilogram meters per minute is the watts times 6.12. So I did that under here. So I did 125 times 6.12, and that gives you 765. Okay, so when you are converting watts into kilogram meters per minute, you get pretty close to one of those 150 marks. So what I mean by that is it's either 600, 750, 900, it could be 450, it could be 300, but it's always within like 15, 20 of one of those. So you're going to round it to whichever one it is closest to. Okay, so in this case, 125 times 6.12 equals 765. Okay, so that means that we rounded it to 750, and I put 750 up here. So why is this significant? We take the 750 and we take the average of his two heart rates, which was 135. So we're going to look at 135 and we're going to run over to right in between 600 and 900. See that up here? 750 fits right in between. Right here. So we're going to take 2.8 plus 3.8 and divide it by 2. And that's what I did right here. So I explained 750 is in the middle of 600 and 900, so we took the average, 2.8 plus 3.8 divided by 2, and that gives you 3.3 liters of oxygen for every minute. Okay, so that is the amount of oxygen that Joe Schmo is using every minute throughout his entire body. So what we need to do is we need to correct that for age. Okay, so you come over here to step 3 and you correct the absolute with an age correction factor. So you go back to your charts. Okay, you see the age correction factor. Joe Schmo is 30. So we're going to go to 30, and his age correction factor is 0.93. So you take 3.3 and you multiply it times 0.93, and that gives you 3.069 liters of oxygen per minute. So basically it's saying as you get older, it's going to bring, the age correction factor is going to bring the absolute oxygen usage down to correct for the process that occurs with age. All right, so step 4 is to make it relative to Joe. So it's great when you tell him you are using 3.069 liters of oxygen per minute, but does that really matter to him? Because you haven't made it relative to his actual body weight. So what you need to do is the first thing is you convert it to milliliters. Okay, so instead of 3.069 is 3,069 liters per minute. And then you divide it by his weight in kilograms, which we said was 74. Okay, so I did that up here. And that is equal to 41.47 mils per kilogram per minute. And this is the value that you can look up in charts and you compare it to other people and you can see how Joe Schmo's doing. All right, so this down here, these are just the instructions for the test overall. If you have any specific questions on this, don't hesitate to let me know. But what I'm going to do now, all right, is you would look at the norms for evaluating the test. And he was 41.47. So he's 30 years old. You go under male, 30 years old. Okay, and oh, he's right here. I was right on it. So he is considered good. He's good aerobic fitness, and that's all the information that you would need to know for that test. Where is it? I just want to get rid of it.